Hello everyone, welcome to my data science channel. My name is Ryan Schul and I talk about a whole variety of different data science topics. Okay, so the project I want to look at today is called confirmation bias, and I think this is very interesting. Let me take you through it, and hopefully you can stick with me to the end because the final results that we calculate I think are very, very interesting. So people tend to act more favorable towards evidence that supports their pre-existing views and belief systems. This is just kind of common sense. It's human nature, right? There's not that much that we can really expect people to do differently, but we can try to intervene in the process and not constantly feed people ideologies and different concepts that already support a certain belief system that they're comfortable with. Sometimes, a lot of times, it's good to see the other side of the coin and understand things from a different perspective. Okay, so confirmation bias in the news and in politics happens when people mostly seek out beliefs that favor information that tend to agree with what they already think, and they tend usually to ignore or to dismiss information that challenges the systems of belief. Okay, so in real life, if somebody already believes a political party is always right, like some people love Democrats, right? Some people love Republicans. They tend to watch certain news channels or read articles that support that party. Similarly, if a news story supports a view, they trust it immediately. If the news story challenges their views, they often question its reality and call it fake news or ignore it altogether. Okay, and this can be very, very dangerous. So let's see why. So here's an example of a person who strongly supports environmental regulation might mostly read news articles that highlight climate change dangers and avoid articles that downplay environmental risks. And another person could be skeptical of climate change, right? And they might favor different media outlets that suggest it's exaggerated and dismiss the scientific reports evidence to the contrary, right? So this can be a very dangerous thing, and let's look at a couple of examples right here. Put together some code. I will share all this code with you guys. Like all of the posts I put here on YouTube, I share all the code, right? So you can download the HTML file and either convert that to a Jupyter Notebook file, or just open the HTML file and copy and paste it into a fresh Jupyter Notebook instance, and then you can run the code and see for yourself. So here I'm creating this just different evidence IDs, okay? Evidence type, and then the strength of the evidence. So is this anti-technology or pro-technology? Okay, I'm just coming up with a couple basic examples here. I looked online for something that I thought would be interesting. I didn't find anything after a short time of searching, so I'm just creating my own data set dynamically here. That's what this is. So you won't find this online, but I think it illustrates the point pretty nicely. So now we can simulate user evidence or evaluation of evidence, and this is people's tendencies to like evidence matching their belief systems more often, right? The opposite would be confirmation bias, or I'm sorry, this is confirmation bias, right? If you offer an intervention, this could show a person or expose a person to something that wouldn't necessarily confirm what they already believe, but now you have a different perspective on things, and you can make a more informed, hopefully more neutral, or more maybe more intellectual type of decision, right? Like if you're always exposing yourself to the same thing over and over, are you really learning anything new? You're probably not, right? So you're going to fulfill, or it's become a self-fulfilling prophecy where you're going to lean towards the thing that you already believe in, okay? So let me create another example of data here. So we're looking at user beliefs, evidence type, evidence strength, and then the rating of that strength, okay? So just like we saw over here, this is a very simple example. I want to try to understand, again, based on user beliefs and evidence type, is there an evidence strength, yes or no, and what's the rating of that strength, okay? So in this case, we can go ahead and plot the results, okay, and try to understand, is this bias, is it actually contradicting or matching, or is it just neutral, right? What's the match type that we are introducing here? So I hit Control Enter to refresh this, and we can look at a few violin plots. I like these. They show you the dispersion around the mean, or the distribution of data And then you can zoom in because this is Plotly, right? And you have all the details here. So it's really pretty nice. You have contradicting median, quartile 1, 2, 3, 4, the max, the min, things like this right over here. And this would be more of a scatter plot, right? So the scatter plot is showing you all the different outcomes of the actual data, and this shows you the dispersion of the data, right? So the fatter, the more wide it is, kind of looking like a violin. In some cases, not always, right? It really depends on the underlying data, but it shows you all these very interesting details of the data. So this one, the neutral, has the smallest min, I see 0.02, and the biggest max, that's 1.0. This min over here is what's hard to read, 4.7, I think, and this one over here is 0, right? So you can see all the different breakdowns of the data within this data set over here. So I think that's pretty interesting. Let's look at the average rating differences in this case. Okay, so the average rating here, we are taking, okay, so we're taking the mean. This is the average. In statistics, it's called the mean. Based on the match type, we're taking the mean of the rating. You can see that down here. So the match type and then the average rating. So confirming, contradicting, and neutral, right? So you can see how media or politics or whatever that confirms what you already know, it's going to be pretty high, right? The match type is pretty high. Contradicting is actually low. This would be some type of intervention event or showing somebody a news article or news story that doesn't match their current system of belief, right? So the contradiction is inherently pretty low. This is just human nature, I believe. And the confirmation, on average, is pretty high. That's what we're seeing here. And neutral is really just neutral. It's just right in between. So let's look at another example down here. Okay, so we have the original summary. Okay, so that's what we had from before. We're going to compare that to the average contradiction, either confirming or contradicting, or is there a neutral outcome after we introduce some type of intervention event. Okay, so here's the original summary. I'm printing some line breaks over here so we can see the differences. Okay, so here's the new summary. This would be the original. Right, that's what we just saw, 79, 29, 49, that's what we saw above. So the new summary, now the match type, confirming 79, 35, and 52 would be the new summary average, right? And we're doing things a little bit different. Now we have the original data frame ratings, right? We're copying that and introducing, what is this? The match type, initial belief, or evidence type, okay? Just to say, like, is this person or is this group of people going to continue to maintain their current system of beliefs, or is this intervention event going to cause them to have a more open mind and say, oh, I never thought of it like that before. That's very interesting. Now you have a different perspective on things, okay? So let me go ahead and plot the results over here. So the original, we had a 0.79 and 0.79, right? So those were the same. Contradicting, originally we had 0.29 and 0.35 after the intervention, and here the neutral doesn't change too much, 49 and then about 51. But it's very interesting how before the intervention, the confirming events were almost exactly the same. After the intervention event, which we introduced over here in this step right here, okay, are we confirming the original rating or are we contradicting the rating? That was the intervention step. So now things are starting to swing a little bit and people are saying, oh, this is very interesting. I like that concept. I wasn't aware of that before, right? So the contradicting event before and after has really changed quite a bit, right? We can see that in the plot. And the final takeaway here is that users already liked confirming evidence, right? That's the 0.89 that we saw, or the 0.80. And that didn't really change. This is what we'd expect, right? Because people align with news that they like, with a political agenda that they like, right? But after being exposed to opposing evidence, users' rating actually contradicted the original rating, and the evidence more favorably matched, and the rating increased from 0.03 or 0.3 to 0.41. That's what we see in this step right here, right? From 0.3 to 0.41. And this suggests that the intervention did work. Users became more receptive to ideas that challenge their initial system of belief, right? So confirmation bias was reduced, That's what we saw in this step right here. And the user rating gap between confirming and contradicting actually narrowed. Okay, so of course, without intervention, people often self-select enter information bias. What is this spelled wrong? Info bias, information bias. Oh, select into information bubbles. Sorry, I misread that. I need to get glasses really soon here. Into information bubbles that continually reinforce their current system of belief, causing confirmation bias, intensification, polarization, reduced openness, and echo chambers, which can be very dangerous, right? In behavioral science and AI ethics, this is referred to as feedback loop of belief reinforcement platforms. I won't name any names, but probably you know one of the most obvious one. That personalized content without safeguards often worsen this effect. So interventions are actually very necessary and very important. But if we don't have these, people just don't have access to different changing belief systems. They can't see things differently. They don't have different perspectives, right? But rather, they keep, to keep minds open and improve media literacy and encourage critical thinking, we should definitely consider these intervention steps and not cause the same people to get the same types of messages over and over and over, right? But be more diverse, more sporadic, more maybe a little bit random or something like that. And a new idea pops up and a person clicks on it and all of a sudden they have a slightly different changing belief system. And I think that's excellent for society, because I think right now, especially in this climate that we're in, post-COVID, people are very narrow-minded and they will not engage in things that that they don't like. That's it. That's the bottom line. But I think some type of intervention from these media outlets that constantly send the same types of messages on these feedback loops just worsen the whole scenario for the people, for people that they interact with, for the entire country of the United States. I think that's the direction we're headed, and it's very dangerous. So hopefully this can change sometime soon, but who knows? Anyways, we did the analysis. We proved the concept actually works, and I think this is a big win. So anyways, I'm going to share the code. I'm going to wrap it up now. I'll share the code with you guys, and I'll post that on YouTube later today. Thanks for your time, and I will see you in the next one. Goodbye.